I think it is just after 8 if we want to get started. Do you guys want to do a quick introduction because we didn't add a slide to introduce yourselves?
That's a great idea. So should we start with Nampreet?
Yeah.
Sure. My name is Nampreet Singh. I work with the FME desktop technology experts here at Safe Software. Love helping our users learn about FME, especially we work with a lot of our onboarding our new users with FME. So excited to present today with Mark and Dale.
Hi, I'm Mark Stokes. I'm with the FME Application Experts team, similar to Nampreet, helping our users get the best out of our products.
My name is Dale Lutz. I'm one of the original 2 co-founders of Safe Software. Been at this for is it getting to be 27 years? I'm losing track, but anyway, a very long time, and happy to be here to show some of the stuff that we actually invented a long time ago, along with stuff that was invented in modern times and how it can all be used in the best possible way.
Nice. Thanks, Dale. I'm Stephanie. I run the webinar program here at Safe. I think this is like, oh gosh, I want to say like our 36th webinar or something this year. So it's been busy, but I'll be helping out on the back end. So any issues, let us know in there. And we also have a Q&A team online. We have Chris, Andrea, and Holly, and they're going to be helping out on the back end too. So please chat your questions into the panel there, and we'll answer things as we go. All right, awesome. Have fun, you guys. I'm going to turn off my camera.
Camera's off, everybody, and let's get at it. Well, thanks everyone for joining us. Today we're going to be talking about some of the foundational pieces of data integration, and that is merging data from different places and joining it and then making decisions. So when we began with FME all those years ago, to be honest, we didn't realize the power that comes when you bring data from different places together. In the very beginning, we were just doing movement of data from one place to another and rearranging it along the way to add the most value when it arrived in the output format. But with time, it became very clear that amazing power comes when you can bring information together from different spots. And over time, we invented quite a lot of different ways of doing that all have their pluses and minuses. And that's what the group is going to be showing us all today, is how to make the best use of these different techniques, when they should be applied, and what some of the highlights and lowlights are. So really glad that you're joining us. We really hope that you leave today understanding that it's actually fairly straightforward to do this kind of merging and joining, and that along the way there's tools that can help you know when stuff isn't lining up so you can take action, because data quality in these things is very important. But there are a lot of paths available to you, and Stephanie made this really cool signpost that we were thinking we should actually sell this at the next maybe, well, it's going to be a while until there's an FME user conference in person, but we could have an online store where you can buy your transformer carved into a hunk of wood. That would be pretty cool. But these are a set of the transformers we're going to be looking at today, from the favorite venerable old feature merger. For the old timers, that's the reference factory from early FME days, all the way through to the most modern of these, which is the feature joiner, the new kid on the block. And along the way, we're going to stop and look at the feature reader, the database joiner, the inline querier, and maybe even a special guest appearance from everybody's favorite, AttributeValueMapper. So all of these transformers that I've just mentioned are in the business of bringing data from different places together. And so for those that are new to FME, and actually if you wanted to just chime in the window, tell us if you're new, we thought we would do a quick little demo to get us started. And so to do that, I'm using this thing we call FME Workbench, which is where we author the flow of data from one place to another. And I want to, my job today is that I've got a data set of the lots in the central part of the city of Surrey, which is where the Safe office is located, where absolutely none of us are today, but that's where it is. And so we have a data set of the lots that my friend Mark has put into PostGIS for me. So I'm saying add a reader. We're going to go and grab those lots out of PostGIS. Oh, nicely set up for me are the defaults. How did I do that? As an aside, I set the defaults ahead of time using this presets business so that I don't have to fiddle around when I'm talking to you. And I can go ahead and add that data set in here. So this is all the lots. And what I wanted to do was make a spreadsheet that I could use to get a feeling as to the allocation of area by different zonings. And so there's a bunch of stuff in here, including a zone code. And so what I can do is use this thing we call feature caching, and I've got that turned on under my run button. And if I run with feature caching, that means I'm going to go out right now and pull all the data out of that PostGIS table, and I can then see it down here. So here it is on a map, and I can go ahead and scroll this and see all the different columns. And I'm actually interested in the area and the code. But man, this is where I could ask Mark. Mark might have these memorized, but I don't know what these zoning codes are. And I know that the person that's getting the spreadsheet isn't going to know either. But Mark scraped for me somehow a file together of these that's in the CSV format, comma separated value. So I got CSV data I can go out and find. And with any luck, the zoning code CSV is right there. I can pop open the parameters, looking good. And I can just say, okay, to add that. And now here's the CSV, which I will just run this to get a sense of what we got going. And it's just a very nice little mapping from the zone codes to the descriptions. Remember, I want to go ultimately to a spreadsheet where I got the descriptions in the areas. And so now it's joining time. And this is where I could use any of those ish transformers, but the one that we would recommend in modern times for this scenario, although I think Nampreet's going to chastise me slightly, and well deservedly so. We'll leave that for him. I'm going to use the feature joiner. And for those that didn't see that, I just clicked on the canvas and started typing feature joiner. I can also type FJ because it knows camel case if you start to know the names of these transformers. And that's really the key of FME, is knowing which of these blue boxes you have available to you to do your bidding, and then you piece them together like Lego and solve your problem. So anyway, I'm going to bring in the lots and the codes, and I'm going to go into the feature joiner, and I'm going to leave this set to do an inner join. And I'm going to tell the team that there's an artificial intelligence opportunity where we could automatically figure out that there's the same column on both of them and load this up. So anyway, I'm joining the zone codes to the zone codes, and now the magic might happen. Yes, and so I've got, now I can actually see some things about my data. The unjoined right are all the zones that actually aren't in the downtown core of the city of Surrey. So that's kind of an interesting thing that falls out. There's 40 of them, which means that the downtown must have 27 that are, and these are the ones that are joined. And if I scoot on over to the far right, I can see I've got that nice description. And so now I'm just about ready to make my spreadsheet. I'm going to put down an attribute manager, which is, I just am typing AM, and I can take and drag this guy, and he's got that nice little green connector thing there, and I can put it on there, and now I'm connected. And I am going to go in here and say that I don't want any of these attributes. I can just highlight them all. I shift click, and then I can say minus. I'm also going to get rid of the code. I'll minus on that. I'll say okay. I open this up. I should only have a couple things. Yeah, the area and the description. And lastly, I will add a writer. And isn't that wonderful? It's all ready to go for a nice Excel writer. I'll set this up to do automatic, which means it will pick up the definitions from whoever I'm connected to. And I will leave it named sheet 1. I could name it something more exciting, but I won't. And I will connect this. And now all of a sudden, I've got this going out, and actually I would like the description before the area. So I'm going to pop this open, go to the user attributes, say that I want to go manual, click on the description, put it to the top, say okay, bloop, they're flipped. It makes that noise, and now I can say just run the whole thing. And now I've got a spreadsheet for me. And if I open up the Excel file, there it is. And I've got my spreadsheet of the nice codes to their areas. And I learned how to do a pivot table, but that isn't what this webinar is about. And you can do a pivot table, and you can quickly find out what the most popular zone is, and so on. So just to recap, what we did was we took a CSV file of codes to their long names, merged it with some lots that were in PostGIS, and got ourselves a nice Excel spreadsheet. So that was my Flash demo. And the point that I hope you got from that is that it's pretty easy to do this. And along the way, you can kind of learn about your data, and FME transformers do the heavy lifting for you. So a few words about FME in general. That's the product we make at Safe Software for all these years. It runs in a few different ways. You have a desktop version for authoring. That's what I was just showing. You build and run the workflows, and maybe that's all you do. You're just doing ad hoc things. That's fine. But then you might make a rule set that you want to run over and over again. So you can push that up to FME server, where it can be run as part of a web app, or every morning at 2 a.m., or whenever a file arrives in a FTP directory. And FME Cloud is just pay by the hour FME server, where we look after hosting it for you in the cloud. Over the years, we've added all sorts of different data formats into FME. So we can do GIS and CAD, that's where we started. And tabular, that's what I was just doing. But along the journey, we of course databases, and all the way up in modern times, even doing some cool things with AR and VR. And that almost all these things, when you're producing outputs, especially on the top end, you're merging things together, these modern formats up here. So one thing to just remember is that while most of our examples today are going to be fairly straightforward, traditional tabular things, you can be bringing all kinds of other data together from totally different places. So one that we just showed in a recent webinar on building information modeling was how we could take data from Revit and merge it with data that was in the IBM system called Tririga to produce a very useful output of high value to consumers of this thing. So radically different places the data lived, but there were keys available to join stuff together. And so we can really do an interesting merge there. After all, our job at Safe Software is to help all of you maximize the value of your data so that your organizations can make the best possible decisions. And I think Don and I have said this over all the years, but boy, it seems like it gets truer with time. We've always said, it's never been more important to make good decisions. And certainly no one would argue with that in 2020. So just by way of agenda, before I hand it off to our main presenters, first of all, we're not going to be talking about joining things spatially today. So we're not going to be looking at proximity or containment or overlay, none of those things. We're going to do a special webinar on that topic in 2021, so keep your eyes peeled for that. Probably we can ask Stephanie to make sure anybody who attends this gets a special invite to that one when the time comes. I will give a sneak hint. We are doing all kinds of optimization for high data volume in this area of FME. So if you're a point and area overlayer, you're going to be in for some happiness in FME 2021. I also want to give recognition to our friend Eric from Spatial Business Systems in Denver. Eric, I don't know if you're here today, but thanks so much for the inspiration. We've got links here to your presentation back in Denver at FME World Tour 2018, which was basically an introduction to this topic. And we've had this on our list for a long time, and so we're finally doing it. But thanks, Eric, for that inspiration. So anyway, we've done the basics. We're gonna hand it off. Actually, no, we haven't done the basics. I think Nampreet's gonna walk us through. We're gonna look at a few different transformers and see some demos. So I think with that, I'm gonna hand it off to Nampreet. So take it away.
Great, thanks, Dale. Can you see my screen all right?
We can.
Wonderful.
Although I'm seeing, yeah, the first slide.
Oh, okay, sorry about that. Let me just skip down to where we were. There we go.
Nice, there we go.
So when we're talking about merging or joining data in FME, you can think of it as extending a table horizontally. So we're basically adding attributes of one data set to another, merging these attributes of each data set into a single fused data set. This is in contrast to appending data sets in FME, where we vertically combine the rows of two tables by connecting their data streams. Here on the left, we're illustrating what happens when you simply combine two data streams in FME. The features or rows from one data set are appended to the other data set in a union. So if we have 3 rows as we have here in each data set, the result would be a table with 6 rows for them. So this is pretty easy to do in FME by, again, combining each of the data streams. Today's focus will be on merging the attributes of different data sets together. On the right here, we have 2 tables, each with different sets of attributes. Column C in this scenario can be used as a common attribute between the 2 tables to perform the join. The resulting table contains all the attributes A, B, C, D, and E from each of the incoming tables and brings in any matches or any matching records that were detected using a common key like column C here. I like to think of the resulting table of a join like this as an enhanced data set or an attribute enhanced data set. And our goal today is to introduce you to transformers that can be used to merge and join your data in FME. Like most things, as Dale mentioned in FME, there are several ways of joining and merging data sets using one of several transformers. Let's check out some of our favorites. We can place these transformers into 2 general categories. The first being transformers that require knowledge of SQL. The other being parameter-based transformers that don't require any knowledge of SQL. A little later in this webinar, Mark will introduce transformers like the inline querier, the SQL creator, the SQL executor, which leverage SQL queries to join and merge your data. I'll be focusing on transformers like the feature joiner, feature merger, the database joiner that allow you to perform joins without having to know any SQL. If you're at a loss and don't know which transformer to use, our own Liz Sanderson from our knowledge team put together this nifty flowchart to help users determine which transformer might be a best fit for you. You can start by determining whether the data set you want to use in a join has already been read into your workspace. Say that you've read in 2 data sets and performed some transformations on them, and then need to merge them in your workflow. In this case, you can follow this internal path and possibly try out the feature joiner. Alternatively, if you need to perform a join on a data set somewhere within your workflow and it hasn't yet been read in, you can consider going down this external path here, using something like the database joiner, which allows you to connect to and join 2 database tables midstream using one simple transformer. If neither of these do the trick for you, then you might want to consider one of the SQL-based transformers in the green box here, or the transformers in the blue box. Just as Dale mentioned, the feature joiner is the new kid on the block. It's received a lot of attention, and its performance has greatly improved, and it's pretty simple to use as well. So when in doubt, the feature joiner may serve most of your needs, regardless of where the data resides in your workspace. Mark and I will touch upon each of these transformers in the following demos, and we'll try to draw out some key features of each for you. Okay, let's start our first demo here. Go into Workbench. So we're going to start with with the case of wanting to join multiple disparate data sets to demonstrate how the feature joiner and feature merger can be used. The goal of this workspace is to generate a report that enhances water meter data in the city of Surrey for a municipal inspection program by supplementing it with additional attributes. Here we have our source data, which is our water meters data set. I've previewed it here for you. You can see it has some basic attributes, but these probably wouldn't be useful for an inspector in the field. So we definitely want to add some more value to this data set for our field inspectors. To show you where we want to get to, let's take a look at our final output to see what we want to provide our inspectors in the field. So here we have our water meters, and for each water meter here, we've added some zoning information as well as address information for each of the water meters. So this is what we want to get to with our workspace. So the first thing we're going to do is take our lot table that we have here, and this lot table contains the zoning codes for each lot. So you can see that this table that we've read in from Postgres contains zone codes. We can use the feature reader to join the zone codes to each of the water meters using a common ID, which will be the parcel ID or PID. So we have a PID in our lot table here and a PID in our water meters table. We've connected the water meters table to the left input port of the feature joiner, since this is the data set that'll be requesting additional attributes. The lots are connected to the right port, and since it will be supplying the additional attributes to the water meter. Let's take a closer look at the feature joiner here. Here, I'll go over some of the parameters that are available. The join mode will determine the type of join that we're performing. For those of you who aren't familiar with the options here, be sure to check out our handy help doc, which you can access from here. And we have our nifty table here describing each of the join modes using these classic Venn diagrams to describe them. Here we're going to choose a left join so that we can retain all the water meter features regardless of there being a match or not. We also have the attribute conflict resolution parameter here, which determines which value to use if an attribute exists in both the left and right tables coming into the feature joiner. In this case, we'll leave it set to use left, and it will use the values coming in from the water meter if there is a conflict with the attributes. We're not going to worry too much about geometry in this webinar, as Dale mentioned earlier, but if there's geometry associated with either of the two data sets coming into the feature joiner, this parameter here, geometry handling, allows you to choose the data sets from which you'd like the geometry to be retained. Finally, and possibly the most important step here is to use the join on parameter to specify the join keys between the two tables that you want to join. you can see here that we have the option of using multiple attributes. So you can add multiple attributes here if needed. This is helpful if you don't have a clear, unique identifier or primary key for your data sets. For this join, we'll again use the PID from each dataset to perform the join. So let's inspect the joined output. We can see here to our water meters table, we've joined the zone code. So again, we have the zone codes that have been joined for each of our water meters using the feature joiner. So we've got a starting point for our zoning information. So the zone code lookup table, which we have here, contains a description for each codes. We'll use the feature joiner here in the same manner to quickly add the zone description to our data stream. This time we'll be using the zone code attribute to join the zone description to the workflow. So we can see here the resulting join. We have a zone description now added to our stream of data. So the next thing we want to add is our address data. So we've got a table here coming in from a CSV file that contains addresses and location information for each of the PIDs. So what we want to do here is use our feature joiner again. This time what we'll be doing is using an inner join so that we can generate two separate reports, one for those water meters that have addresses associated with them, and another report containing water meters that didn't have any matching addresses detected. So you can see here under the join port, all of these are the water meters that have a matching address associated with them. And then the unjoined left port here contains the output of any water meters that didn't have an address associated with them. So in this demo, we managed to take multiple data sets from a variety of formats. So we have a JSON, Postgres table, Excel, and CSV files, and merge their attributes together in a succession of joins to generate an enhanced water meter report. So just a quick look again at what our final report looks like. We've got our water meter records here, and for each we've got our zone descriptions and address information. Let's explore how the feature joiner handles one-to-many joins using the feature joiner and also highlighting a use for the feature merger. We'll collapse this bookmark and bring this up here. What if we wanted to add some additional property details, such as the folio number to this address table here? So let's just set this up. So we've got our address table, which we used in our previous example, and I'll join this to the feature joiner, along with this table here that contains some additional details for each property, including a folio number. So an address can be associated with one or more properties. Think of townhouses, apartments, or commercial units. For this one-to-many scenario, the feature joiner returns returns separate address features for each match in the property details table. So basically, we have about 2,000 records coming into the feature joiner from the addresses, and we can see out of the join port, we have about 13,500 joined records coming out, which means we had more than one match for a given address. The takeaway here is that by default, the joiner will create separate address features for each match that it encounters. Let's take a look at the feature merger, which I have set up here already. So let's disconnect that and connect the addresses to the feature merger and see what happens. By default, it generates only one feature per address, regardless of the number of matching addresses, which may not be ideal for some one-to-many joins. But suppose we want to create a list of all folio numbers from the property details table here for each of the address records. Let's open up the feature merger. And what we'll do here is enable process duplicate suppliers and generate list. What we're going to basically do here is create a list for each of the address records to hold all matching folio numbers for each address. So we've created a list name called folios, and we selected the existing folio attribute coming in from the property details. So let's inspect the merged output. I know we have this address here that contains several matching property records. So if we inspect this and look at the feature information here, open up the feature information window, and we can see that we've generated a list here called folios. Oops, I don't know why it didn't. Let's try to find a record here that has more than one address associated with it. Let's see here. Here we go. So we can see that this record here, we've managed to create a list called folios in which it's detected 2 folio numbers, and we've collected those folio numbers into this list for this record. We can further improve the output here by adding a list concatenator, which will basically concatenate this list and expose it to the table here and join all the folio numbers into one record here. So if I look at this one here, we've concatenated the 2 folio matches for this one address. So I hope this demo gave you a sense of how easy it is to join tables using the feature joiner and where you might want to use the feature merger. So here's a nice reference taken from one of our tutorials in the FME community that describes the various join modes available, again, using those classic Venn diagrams. And it also describes which features are coming out of the output ports on the feature joiner. Be sure to check out the tutorial and documentation for more information on the feature joiner. Here are some of the points we covered for the feature merger. Again, generating a list to capture multiple matches. We also have a link here to a tutorial on how to work with list attributes in FME. Just comparing the feature joiner and feature merger, the feature joiner is simpler and faster than the feature merger in most cases. I find it easier to work with different cardinalities as well. As we just demonstrated, the feature joiner also supports multiple matches per record by default. With the feature merger, you can merge multiple suppliers to each requester by generating a list of matches as I showed just now. But when in doubt, I always like to start with the feature joiner. It's always a good starting point.
The feature merger, even the last point there, it can create geometries, and you might wonder what in the world is that about? And that was because its underlying technology was built to read E00 files. So I'm wondering how many of the folks out there even remember what E00 files were, but that's how long this thing has been around. I don't know that ability to create geometries, if each of the suppliers has a line, we can turn them all into a polygon if they know the polygon ID that they're with. So that's that obscure functionality at the bottom there.
Thanks, Dale. Let's go into another demo, and we'll be looking at the database joiner as an alternative to the feature joiner. So this should look familiar. This is basically the same workflow that we were looking at before, using succession of feature joiners to produce an enhanced water meter report. The database joiner basically allows you, which I have the database joiner here, so it allows you to connect and join your database tables to the incoming data stream, all within one transformer. We're going to replace the feature joiner that you also saw Dale demo in a similar scenario to use a lookup table to bring in the zone descriptions to our water meters. So what we could basically do, we can get rid of our lookup table and feature joiner that we used previously to bring in our zone descriptions. Let's delete that. And we can simply connect our database joiner in place of those two. And let's open it up and see what we have in here. So you can see here that the database joiner has basically an embedded reader that allows you to connect to any database format, as well as Excel and CSV files. Our lookup table in this scenario is an Excel spreadsheet, so we're pointing to an Excel file here. Similar to other transformers we've seen, we need to specify at least one common attribute to join on. We're using zone codes here, as we did in our previous example, to bring in the zone descriptions. A neat little feature of the database joiner is having the ability to have upfront control of attributes that you want to join into your data stream. Other joining transformers just bring in the entire set of attributes from one table into the workflow. So here with the fields to add parameter, you're able to select which fields you want to bring into the workflow. So for our example here, all we really need is the zone description. Setting the intended cardinality is also a bit more straightforward with the database joiner, especially for those who work with databases. You might appreciate this a bit more. So for this case, I chose to select must match 0 or 1. features coming from the lookup table. And then further down, we have accumulation information similar to accumulation information conflict resolution parameters that are similar to the other join transformers that we've seen before to handle how we're going to join the attributes and resolve any conflicts between the attributes. There's a little section here down below, which basically is enabled when you choose a database format, which allows for better performance if you're working with a subset of records within a database table. You can set up a prefetch query, which is basically like a select statement, SQL select statement, and you can let the underlying database do the work in bringing in a subset of data to join into your workflow before actually making any matches in FME. So let's see what we get as an output here. We can see here, similar to our previous workflow, we managed to get the zone descriptions attached to our water meter records in our data stream here. Though it helps with decluttering your workspace, in my opinion, for most joins, you'll likely experience better performance with the feature joiner. The one place we don't mind using it, like we demonstrated here, is for doing quick lookups. So if you want to do a quick lookup, the database joiner might be a good fit for you here. So here's a summary of what we just talked about. Check out the tutorials and documentation about for more information on the database joiner. Comparing the database joiner with the previous two transformers we talked about, the feature merger and feature joiner. One thing I didn't mention is that the database joiner is a non-blocking transformer, which means that the data is being joined as each row flows into the transformer. On the other hand, with the feature joiner and feature merger, they hold or block features from being processed until they've all been read and or brought into the transformer. With the database joiner, it allows you to connect to and join to database tables midstream with one easy transformer, and it allows you to select which attributes you want to join on. So if you're joining to a large table and you only need a couple of attributes, this might be an attractive feature for you. It also has explicit cardinality parameters, and it's, like I mentioned, it's really good for doing quick lookups. With the feature joiner and feature merger, you can connect to all FME readers and not just limited to database formats. And you'll likely see better or comparable performance with the feature joiner as well.
So I'll just jump in quickly. I know we're getting tight on time, so I won't get into too much, but I wanted to throw in that there is another transformer called the AttributeValueMapper that basically is like a database joiner where ahead of time you put all the things you want to join in the workspace. So the advantage is you don't have anything external to rely upon. The disadvantage is if you want to modify any of the lookups, you got to crack open the workspace and make some changes. So again, it's good for one-to-one lookups where you know that it's never changing and you just doing it to be fast. And you can import from somewhere, but it is saved with the workspace on the AttributeValueMapper. And so that's all I'll say on that, and you can take it back.
Thanks, Dale. one other midstream transformer that we can use for joins is the feature reader. It basically allows you to join with any database or spatial format with an existing data set in your workspace. It's typically used for spatial joins, which we'll get to more about that next, hopefully next year in part 2 of this series. But you can also perform a quick join with database tables. The way you do this is you create a where clause that associates the attributes from an incoming table being read in by the feature reader to an attribute coming into the feature reader from your workflow. You'll also have to set the accumulation mode parameter to merge initiator and result, as you can see down here. And just a quick comparison of the two, both read and join data midstream. The database joiner, as mentioned, allows you to join database formats as well as Excel and CSV files, whereas the feature reader only allows you to create inner joins with database formats. And with that, I'll hand it off to Mark.
So what we were looking at earlier on with Nampreet is the feature joiner and a couple of other transformers. And in Nampreet's workspace, I noticed that just a couple of other transformers like an attribute manager or something would quickly push us over Don Murray's limit of 10 transformers per workspace. So the feature joiner is great, it's very fast, it's SQL free, but if you want to do multiple joins, you have to chain them together. So we have another transformer, the Inline querier, that allows you to do multiple queries within a single transformer. It uses SQL, so if you love SQL, this is a great transformer for you. It allows you to do multiple queries on different tables. It allows you to work with data that is already loaded into FME, so you can work with multiple data sources. It loads a temporary workspace, not a temporary workspace, a temporary SQLite database. And once that's loaded, it's pretty fast to work with. So as I said, any data source, using your knowledge of SQL, multiple queries in one place. Like most of these transformers, it does support spatial if you have some spatial data columns with it. If you're not familiar with SQL, there's some great online resources around that, and I put a link in here for the SQLite tutorial because you do have to use the SQLite flavor of SQL to work with this transformer. So what does that look like? We can have a look at a workspace I've already built that's based around the same data that Nampreet was illustrating and showing us earlier on. I'm going to just quickly get that running, and we can see how that works there. And so in the inline querier, you can see we have the input ports that come in with multiple tables that are going to represent the tables we're going to work with. And then what we can do is we can build any SQL query that we like, and that will produce a result that comes out here and is generating the same reports that Nampreet was creating with those SQL queries. So just how would you start working with this? I'm just going to start adding an inline querier. It's one of the transformers that has dynamic ports on it. So as you start connecting inputs, it starts building the new ports for you. And so that's kind of a different experience for users. It doesn't have an output port at this point in time. So here are my two tables that I want to join. And then I'm going to say what output port I want to add. I'm just going to call that the join. And then I can start building my SQL. I can look at all the databases or the tables that I've loaded into this temporary database, look at the attributes as well if you want to do that. And we've got some shortcuts available to you. So I'm going to start to build a quick query here. So I'm going to select from, and I'm going to do a left to join on the lots, and we'll call that table L, and we're going to join on, and here we can start looking at the attributes that we want to work with. We're going to join on W and PID, and where that equals table L, which is our lots, and we can look at those because of course the keys might be named differently. And so that's how we build up the table, and then with feature caching we can run that as well. Okay, so that's using the SQL, the inline query. So just a couple of tips around that. One of the things that's going on in this inline query is we're loading that temporary SQLite database, and we're indexing all the attributes in here. So one of the things we can do is to reduce the amount of time to set up that SQLite database is only reference the, or only preserve the attributes that we need within the SQL query itself. So if these are the only two attributes we're going to work with in the SQL queries, we can remove the rest, and I'll show you how that will work in a second. There we go. So we're going to get rid of all of those. So now we've reduced the amount of indexing that we're doing on that SQLite database. But here, what you can see is when we look at the database tables and we look at one of the tables here, we've got a special attribute called the FME feature content. And what that is that attribute is a blob that preserves all the attributes that are on the incoming feature, and FME will recover those for us on the output. So the only attributes we need on the actual table are the attributes we're going to use within our SQL query, and FME will index those, so the queries are very fast. So reducing the number of query attribute columns that we expose in each table will just speed up the actual creation of that temporary SQLite database, and then it will really sing for you. So tips for the inline querier: it loads this temporary SQLite database, so it does take a little while to do that, but once the data is loaded, it's very fast, so you can consolidate a lot of your queries into a single transformer, so that's great. Because it does load a SQLite database, don't use this transformer for very simple tasks like filtering. We have seen users who are very comfortable in SQL do things like filtering or even attribute mapping, like the AttributeValueMapper that Dale was showing earlier on. So that's a natural thing to do if you're very comfortable in SQL, but of course you've got this overhead of loading the SQLite database. So when you do that, you want to make it worthwhile. So remember to use that smart configuration to improve performance. Only define the input columns that you need within your queries. So that's the SQL inline querier transformer. Again, any data source can be used and utilizes the power of SQL if that's where you're comfortable. But what happens if all your data is in a database? So we've been talking about kind of rather disparate data sets where our data is scattered between a database or maybe different databases, and also CSV files, Excel files, maybe even some shape. But a lot of the time your data is already in a database. And so what we can use is a couple of other transformers, the SQL executor and the SQL creator, that will allow you to build SQL calls right against those databases. So possibly out with the SQL executor and, out with the inline querier and in with the SQL executor or the SQL creator. Now these transformers are actually exactly the same, except for the SQL executor has an initiator port, and so that requires a trigger. I'm using a creator here, but it does mean that you can actually build multiple queries and fire those into the SQL executor with different attributes to create different kinds of results. So that's one of the powers of the SQL executor. The SQL creator is similar to the creator. It just fires off as soon as you start the FME workbench and start your run. And so that will kick off your SQL query right off the top. So just a very subtle difference between those two transformers. Otherwise, they're exactly the same underneath. Of course, so your SQL executor needs a database underneath. It utilizes the power and knowledge that you might already have in SQL. Again, it can include spatial columns if you have them. So you can query back the spatial columns. And you can use any SQL in these transformers actually. So you can select data, which is what I'm going to illustrate here, but you can also use these transformers to fire off any SQL you need to your database. So you can create indexes, you can drop tables, you can create tables, anything that you can do in your database, you should be able to do within these two transformers. And just bear in mind that the SQL you use will be the flavor of SQL that is used by your underlying database. So that there are subtle differences between the SQL in Oracle, SQL Server, Postgres. So just bear that in mind. And also just remember, you don't have to just read data, you can fire off any SQL you want. So let's have a look at a workspace that works with this data. And again, I've got the same source data, except now loaded into a Postgres SQL database. I'm doing the same queries that we've been looking at before between the lots and the addresses and the codes. So what does this look like? Let's get this one running here. Very fast. In this case, I'm working with a Postgres database that's local on my little laptop here. And I'm actually using a slightly larger data set than what Nampreet was using for the whole of Wally rather than the just the center of Surrey. So here, our first query, I've got joining to my Postgres database, and this is the query I got, and we've got the same SQL building tools that you saw in the inline querier, so you can build those SQL statements, any statement you want. We've got shortcuts as well that you can use, so you can get ideas for dropping, duplicating, truncating tables. So lots of different shortcuts queries that we've got already in there. It's got a run button here that will allow you to test your query just quickly so that you can see whether you've got your SQL done correctly and make sure the connection's working okay. So quite a lot of helpful tips there. Again, it's got the combine attributes, how you want to combine the attributes onto the results, keep some of the attributes from the initiator, and keep the results if there's a conflict. So lots of choices on how you accumulate attributes as well. SQL Creator is the same, has all the same tools, except it will just fire off by itself. Now, sometimes when you're working with databases, the ordering of your features is important. So in this case here, I've got a creator starting, firing off the SQL executor. The results of that query will be output. And then once that query is complete, it will output the initiator feature that came in, and I can use that to trigger a second query. So this query will have finished, and then we will trigger the second query here. In this case here, the SQL creator is just starting off. So one of the things to remember about the creator transformers is you can set the runtime order of the different creator transformers in your workbench. So if we want that SQL to fire before these other two, we can trigger that SQL by moving the SQL creator up, and this guy will run first. So quite a lot of good options on our SQL creator. And the great thing about this transformer is that it's letting the database do the work. So you're only going to load the data that you actually want to work with in Workbench. So all the other examples using feature joiner and feature merger, we've had to read, and sorry, the inline query, we've had to read the data first, and then we're going to process it. And in some cases, doing those joins, you're throwing out some of the data that you don't want to work with. Whereas with the SQL Executor and SQL Creator family of transformers, you let the database do the work and you only load the data you need, which is why they're so performant. Okay, one other little irritation with the SQL Executor Creator family is exposing attributes. So this used to be super awkward because FME doesn't know what attributes. I haven't got feature caching on here, so I'm just going to rerun that. It doesn't really know what attributes are coming out here because it doesn't really look at the SQL and figure out all the attributes. So when we look at the intermediate results in feature caching, when this is just finished in a second, there we go. Okay. What you're going to see when you look in Workbench is in Data Inspector is, if I can drag that across onto my window, here it is that we're not really seeing any schema on this feature. Now, that's a bit of a fib because the attributes are actually there, but if we want to rename some of the attributes and work with them in Workbench, they're not actually exposed to the Workbench schema. But in the more recent releases of FME, what we've done is we've allowed the attribute exposer to find attributes that are on our features. So I can add in here attribute exposer, and then we can see that we haven't got any attributes exposed. But down here, I can import those attributes from the feature cache, and we can pick the attributes that we might want to preserve with and work with in Workbench. Actually, I could just select them all. I don't know why I'm clicking away like that. And then I can import those. And so now those are accessible to me within Workbench. And when we open up Data Inspector, we'll see that they're all there. And so now adding other transformers like Attribute Manager and so on, we'll see that those attributes have all been exposed and we can work with them. So exposing attributes, use the attribute exposer, and I think fairly soon what we're going to be doing is pushing that functionality back right into here where you can expose the attributes here from the feature cache, and that will come pretty soon. So watch that space for that change. Okay, so that's the SQL Executor and SQL Creator. Great transformers if all your data is already in a database and you want to let the database do the work for you. So a couple of other join ideas that we're not going to dip into in too much detail here is, of course, you can use database views, so you don't actually have to do the joins in FME either. So if you've got views, FME can read those, and you could create those views with SQL Executor or SQL Creator, and then have FME read them, or you can use views and just use the regular database readers to access that data. So that's another way of getting the database to do the work, using views. And then in highly managed databases, sometimes those database managers don't like you accessing the underlying tables directly. So that's kind of for complex databases like Salesforce, SAP. In this case, we're looking at IBM Tririga, which is a space management tool. And so some of those API calls that are available for those highly managed databases will allow you to do joins through the API. And a colleague of ours, Dave Campanis, he's written a couple of custom transformers that are available on the FME Hub for working with the Tririga space management platform. and he's written a TriRiga record fetcher using their API, and he's also written a transformer, the TriRiga associated record fetcher. So that will look for associated records and join those through the API and bring those features back. So that other ideas for doing joins are available to you, as well as the transformers that we've been looking at. Well, in many cases, you want to automate this work or share your work with other people. And so that's what the FME server product that we offer is all about. And so Nampreet built an FME server app and built an app gallery that would allow somebody else to run our water meter report. So I've just got the link here. It's going to open up my FME server gallery app. Very quick way of building a nice interface to run a workspace. In this case, we don't really have any parameters for this water meter report. It's just going to dig into the database, and it's the workspace using the SQL creator and SQL executor that I was showing. And if we just run this, it will offer us a copy of that report, and we should be able to get that. And I think I've got another version of that here, which is the native FME server. And so this is the published workspace that is that SQL executor. I've got it set up for data streaming. So we could either run that here, or we could actually put this on schedule and have it dump out the meter report every morning at 6 in the morning so that other people can grab it. But and that enables people to get the very latest data from that PostGIS database as people are keeping it up to date. So in this case, it's a streaming response that I've set up, and so I'm getting the report back. But again, we could put that on a schedule and have it output that report for everybody every day at a regular time. So lots of options there for our for automating your workflows. Now I've lost my, okay. And here I have put in a lot of references and resources that you can use if you want to get started with FME server around the idea of automating your workflows. Okay, so here's the beginning of the end of the summary of our little webinar here. So choosing the right transformer, you can merge and join data very efficiently in FME. Got a few options, and we've got the flowchart that Nampreet was showing earlier on to help you choose which of the transformers to use. So your choices are, is my data already loaded, in which case you're kind of going to be working with the feature joiner, the feature merger possibly, or is all my data, and maybe the inline querier, sorry, or is my data already all in a single database, in which case we can let the database do the work and use the transformers like the SQL executor and SQL creator. And of course, if you're not comfortable in using SQL, then maybe you want to use one of the SQL-free transformers like feature joiner or feature merger. If you're very comfortable in SQL, then you have the option of inline querier and SQL executor. I'd suggest you use what you're comfortable with, and if you're new to FME, we would suggest that the starting point is probably going to be feature joiner, work from there. You can always change things later on, and so nothing is set in stone when you're working in FME. Of course, just a quick shout out to the City of Surrey Open Data website, where we've been grabbing all this data and pulling it down from. So that's a great resource for us for when we're doing demos and anybody else interested in the City of Surrey. A couple of additional resources here to get you going. There is a tutorial on merging and joining the database data, so have a look at that, as well as the flowchart that Nampreet showed us. Under any of the documentation for these transformers, there's a section choosing the feature joining method. And so that's just down a little bit. Looks like that's not going to scroll down for me. Anyway, it's a little bit further down the workflow here. There we go. Joining transformers, the comparison matrix. There it is. And so that gives you some tips on which of the transformers to use. Okay, so if you're new-ish to FME, gather up your data, choose a transformer to do some merges and joins, get going with a free trial or upgrade, and then if you feel that's working for you, think about automating that process so that you can either schedule it or share it with other workers in your organization. We've got many different ways of you getting access to FME through different licensing options. We have enterprise subscriptions, which are tuned often to the size of your organization, or if you're a municipality, for example, it's based on the population of your municipality, what the subscription is. So that's a yearly subscription to get both FME desktop and FME server. Or if you're more comfortable with perpetual licenses, we have node-locked or concurrent licenses in the traditional form for both FME and FME desktop and FME server. And we also have cloud deployments, FME cloud, which is a cloud deployment of FME server. And we also have FME available on some of the marketplaces, Google Marketplace. So that's many different ways of getting access to the software if you think it's going to fit your needs. And so with that, from myself, and I think Dale is still with us somewhere, I'll say
Yes.
It's from me, and it's goodbye from him and Nampreet.
Yeah. Thanks, everybody. And everybody, thanks for joining in. And we'll look forward to seeing you in the new year when we talk about another way of joining things, and that's spatially. So,
Yes.
all right, that's it for me.
Great. Thanks very much.